Hi all, let's start Maths, Grade 11, Chapter 2, Relations and Functions, Subtopic Functions. Learning Objectives. After this session, learners will be able to define the concept of a function, differentiate between various types of functions, apply the rules of algebra of functions to solve problems. Introduction to function. Function. What is a function? Function is a relation f from a set A to a set B is said to be a function if every element of set A has one and only one image in set B. So set A should not have this more than one image of the set B. For the each element, I mean. If f is a function from A to B and A comma B belongs to f, then f of A equals to B, where B is called the image of A under f and A is called the pre-image of B under f. What is a real function? A function which has either R or one of its subset as a range is called as a real valued function. Further, if its domain is also either R or a subset R is called a real function. For example, let n be a set of natural numbers. We'll define a real valued function f of n such that n by f of x is equals to 2x plus 1. Using this definition, we need to complete the given table. So, here x is a 1, then y value is f of 1. That is, instead of the 1 x, we substitute as a 1. So, 2 ones are 2, 2 plus 1, 3. So, it will come as 3. Similarly, when we substitute x as a 2, we are going to get as a 5. Then similarly, when we are going to substitute as a 3, we are going to get as a 7, then 9, then 11, then 13, then 15. Therefore, the completed table is here. When x is a 1, y is a 3, x is a 2, y is a 5, x is a 3, y is 7, x is a 4, y is 9, x is a 5, y is 11, x is 6, y is 13. When x is 7, y is 15. That is f of 7 is 15. Some functions and their graphs. Identity function. This is one function. Let R be the set of real numbers. Define the real valued function f. R belongs to R by y is equals to f is equals to x here. So the definition of the function is y is equals to x. For each x belongs to real values. Such a function is called an identity function. If we observe the graph here, this is an example for the identity function. For if x is 2, y is 2. If x is 4, y is 4. If x is 6, y is 6. If x is 8, y is 8. Similarly, coming to this negative side, if x is minus 2, y is minus 2. If x is minus 4, y is minus 4. If x is minus 6, y is minus 6. If x is minus 8, y is minus. If we observe here, both x and y values are same. If we plot the graph, we will observe like a straight line, and which is passing through this circle and this in this first quadrant and the third quadrant. Constant function. Constant function is like define the function f such that with the real numbers by y is equals to f of x is equals to c, where here x belongs to real numbers, where c is a constant and each x belongs to real value. Here domain of f is R and its range is c, because the range of this constant function is always only constant only. So irrespective of this x value here 2, 4, 6, 8, y value is always 3. So we can define as a y as 3. This is a constant function example. If we'll take x as a minus 2, we are getting y as a 3. We'll take x as a minus 4, we are getting y as a minus y is a 3. We are getting x as a minus 6, y is 3. So irrespective of all values of x, we are going to get as a y is a 3. So this one is a constant function. Polynomial function. A function f R said to be polynomial function if for each x in R, y is equal to f of x is equals to a0, a1 of x, a2 x square, dash dash, an x power n, where n is a non-negative integer and a0, a1, a2, an belongs to real values. The function defined by f of x, x cube minus x square plus 2 is an example of polynomial function because it has a consist of this x cube, x square, and which is in the form of a0, a1, x, a2, x square. And similarly, other example is g of x is equals to x power 4 root 2x. Examples of the polynomial function. Rational functions are functions of the type f of x by g of x, where f of x and g of x is a polynomial function and x is defined in a domain where g of x is not equal to 0. This rational function is like we have to keep it in mind a rational number. A rational number will define it as p divided by q such that p comma q belongs to integer but q does not belong to 0. Same here, instead of the p will replace with the one function f of x, instead of the q will replace with the g of x, and we should ensure the denominator of the g of x should not be equal to 0. This is a rational function. The modulus function. Function f with its real number defined by f of x is equal to modulus x. So here two standing lines will define as a modulus f x. For each x belongs to R is called a modulus function. For each non-negative value of x, f of x is equal to x. But for negative values of f of x, the value of f of x is negative value of x. That is, for example, if we take f of x as a function, then we will define a function such that x, the value of f of x equal to x if x is greater than or equal to 0. For all positive values, this is x only. And f of x is equal to minus x if x is less than 0. For all negative values, it will be the minus of the given value. So that's why if you plot a graph of this one, f of x is a mod x, this example here. So when we will take x as positive, we are going to get as x only. When we are going to take the x as a negative minus 2, then what is the value here? Minus of minus 2 will be this plus 2. So y value should be plus 2. This, if we take x as a minus 4, y should be plus 4. X as a minus 6, y should be plus 6. So on plotting the graph, we are going to get. This is an example of modulus function. Signum function. The function f R belongs to R defined by f of x is equals to 1 if x is greater than 0, is equals to 0 if x is equal to 0, equal to minus 1 if x less than 0 is called a signum function. So for all negative values it will come as minus 1. If for all positive values it will come. So for 0 only this will belongs to 0. So this is this signum function. The domain of the signum function is R and the range is a set of minus 1, 0, 1 because it values only for these three values. The graph of the signum function is given in this figure. See, for all the positive values of the x, like we are going to use y is a 1. With the 0 values, 0. For negative values of the x, we are going to get y as minus 1. Next one is the greatest integer function. The function f R belongs to R defined by f of x is equal to function x. X belongs to R assumes the value of the greatest integer function less than or equal to x. So here this one will denote with this square brackets. Okay. Such a function is called a greatest integer function. From the definition of this greatest integer function, we can see that greatest integer function equals to minus 1 for minus 1 less than or equal to x0. So for all the values from this 0 to minus 1, the value will be like minus 1. From minus, and it will be like a positive 1. It will be 0 if value of this x is greater than or equal to 0 and less than 1. So for all this one will be like a 0. Next it will be 1 for all the values of x greater than 1 and less than 2. For all this value will be 2. Similarly, for this 2 to 3, the value will be 3. So the 3 to 4, the value will be here 3. Similarly, when x is here, the 0 to minus 1, that value of the y value will be minus 1. And this x is minus 1 to 2, the value of the y is minus 2. Similarly, when x is from minus 2 to minus 3, the value of y is minus 3. So, x is from this is a 0 value. So, the graph of the function is here as shown in the figure. Algebra of real functions. Addition of two real functions. Let f with this x to the tending to the real values, the g of x coming with the real values, be any two real functions where x is subset of R. Then we define f plus g such that x tends to R by f of plus g of x is equals to f of x plus g of x for all x belongs to capital X. So here, when we are adding this f of f plus g of x is that nothing but f of x plus g of x. So we are, this one is an addition of the two real functions. Second one, subtraction of a real function from the other. So if the f of x is a one real function, g of x is real function, then f minus g of x, we can make it as a f of x minus g of x for all x belongs to x. Similarly, multiplication by scalar. So when we are multiplying a function with this real valued function with a scalar, here the scalar will mean a real number. The product alpha of f is function from x to r defined by alpha of f. This is nothing but alpha of f of x. X belongs to. So we are multiplying this entire function with this the scalar value alpha. Fourth one, multiplication of the two real functions. When fg of x is a multiplication of this one, the product of the two real functions f x belongs to r and g x belongs to this r is this function fg x tends to r defined by fg of x is equals to f of x into g of x for all x belongs to capital X. This is called as a pointwise multiplication. Quotient of two real functions. Let f and g be two real functions defined from x tending to r, where x is subset of r. The quotient of f by g denoted by f by g is a function defined by f by g of x, that is f of x by g of x, provided g of x is not equals to 0. Let us see exercise 2.3. First question. Which of the following relations of functions give reasons? If it is a function, determine its domain and range. So here we need to find out which are the functions and we need to give the reason and we need to find the domain and range. First one. As per the definition of function, a relation f from set A to a set B is said to be a function if every element of set A has one and only one image in set B. So therefore, the first one is yes, this is a function because 2, 1, 5, 1, 8, 1, 11, 1, 14, 1, 17 is a function. Every element of the first set has only one and only one image. If you observe for the 2, 1, 5, 1, 8, 1, this 11, 1, 14, 1, 17, 1. So 17 does not have the other one. So it's only 1. Therefore, domain equal to set of first elements in pair of function. 2, 5, 8, 11, 14, 17 is a domain. This range is set of second elements in the pair of function, that is 1 is a range. Second one is also a function, yes, because 2, 1, 4, 2, 6, 3, 8, 4, 10, 5, 12, 6, 14, 7 is a function because every element in the first set has one and only one image. This domain is equal to set of first element in the pair of function, that is 2, 4, 6, 8, 10, 12, 14, and the range is equal to set of second elements in pair of function, that is 1, 2, 3, 4, 5, 6, 7. Third one is it's not a function because here for 1 value is 3, other value is 5, so it's not a function because the first elements are 1, 1 and 2, but 1 is present twice here. So 1 has a value of 2, 1 is also having this value as a 5. Therefore, this relation is not a function. Let us see question number 2. Find the domain and range of this following functions. First one is f of x is equals to minus mod x, and second one is f of x is equals to square root of 9 minus x square. Solution. Given function is f of x is equals to minus mod x for all real values. Mod x is valid. Let us validate with some values. Let us take x as is minus 1. Then we will get f of x as is minus modulus x. What is the minus of modulus x? Minus of modulus 1 is minus of plus 1. So we are going to get as a minus 1. So is it real? Yes. Then 0. If you substitute x as is 0, modulus of 0 is 0, minus 0 is also 0. Is it real? Yes. If you substitute x as a 1, we are going to get as a modulus of x as is 1 and minus of modulus x is minus 1. Is it real? Yes. Therefore, the domain values, it will be from minus infinity to this plus infinity. So it goes to this from minus infinity, minus 2, minus 1, 0, 1. So it's a R values are all real values. And this range is from whatever the values we will take, we'll end up will only till 0. It will not go beyond this 0. So from the negative values to positive 0. And the 0 is included with when the value is 0. Therefore, from the 0 we are making it as a closed bracket here. So the minus infinity is an open bracket. Let us see question number 2. Given function f of x is square root of 9 minus x square. Now, let us validate with this p values. If we take x as a minus 4, we will get as f of x as minus root 7 under root. Therefore, is it real number? No, because this is a complex number. When it's a negative of this root comes as, this will come as a imaginary values. That is root 7i. Therefore, it's not a real values. If we take x as a minus 3, then we will get f of x as 0. Is it real? Yes. If we take x as minus 2, we will get f of x as root 5. Is it real? Yes. If we take x as a minus 1, we are going to get as a f of x as root 8. Is it real? Yes. Similarly, till 3, the valid is all real numbers. When we will substitute x as 4, then again we are going to get as minus root 7, which is an imaginary, it's not real. Therefore, the domain is from minus 3 to 3. That is, x such that minus 3 less than or equal to x less than or equal to 3. The range is 0 to 3. X is such that 0 less than x less than or equal to 3. Let us see question number 3. A function f is defined by f of x is equal to 2x minus 5. Write down the values of f of 0, f of 7 and f of minus 3. Solution. Here, given the function is f of x is 2x minus 5. Now, substitute x as 0. So, f of 0 is, x is 0 will substitute, then 2 into 0 is 0, minus 5 is minus 5. F of 7. Substitute x is 7, so 2 7s are 14. 14 minus 5 is 9. Therefore, f of 7 is 9. F of minus 3. Substituting x is minus 3 in f of x, we get f of minus 3 is 2 into minus 3 minus 6. So, minus 6 minus 5 is minus 11. Therefore, f of minus 3 is minus 11. Let us see question number 4. The function t, which maps the temperature in degrees Celsius into temperature in degree Fahrenheit, is given t of c is equal to 9c by 5 plus 32. Find first one t of 0, t of 28, t of minus 10, and the fourth one the value of c when t of c is 212. Solution. Given t of c is equal to 9c divided by 5 plus 32. T of 0 means instead the c substitute is a 0. Therefore, substituting c equal to 0 in t of c, we get t of 0 is equal to 9 into 0 divided by 5 plus 32. 0 divided by 5 is 0. So, 0 plus 32 is 32. Therefore, t of 0 is 32. Next, t of 28. Let us substitute c as a 28 in t of c. We will get t 28 as 9 into 28 by 5 plus 32. 9 into 20 is 252. By taking LCM 5. So, here 32 into 5 is 160. So, 252 plus 160 divided by 5. 252 plus 160 is 412 divided by 5. Third one, t of minus 10. Substituting c as is minus 10 in t of c, we get t of minus 10. 9 into minus 10 divided by 5 plus 32. 5 ones are here, 5 minus 2 are. So, 9 into minus 2 is minus 18. Minus 18 plus 32 is 14. Fourth one, it's given t of c is equal to 212. Now, we know that the function t of c is a 9c divided by 5 plus 32. So, 9c divided by 32, 9c divided by 5 plus 32 is equal to 212. This implies by transposing 32 to the other side, we'll get 9c divided by 5 is equal to 180 because 212 minus 32 is 180. Now, again let us transpose this 5 to this other side. Therefore, we'll get c is equal to 5 by 9 into 180. 9 ones are 9 20s are 20 into 5 is 100. Therefore, c is equal to 100. Let us see question number 5. Find the range of each of the following function. One, f of x is equal to 2 minus 3x. X belongs to R. X is greater than 0. Second one, f of x is equal to x square plus 2. X is a real number. Third one, f of x is equals to x. X is a real number. Solution. F of x is equals to 2 minus 3x. X belongs to R. X greater than 0. Given x is greater than 0 in this. Okay. Then, when x is greater than 0, when we multiply both sides with the 3, so 3x into x is, what is this? 3x is greater than 0 because by multiplying on both sides with 0. Again, when we multiply with this minus, that will become less than 0 because when we multiply the greater value, for example, if we take 16 is greater than 9, when we multiply with this minus, then minus 16 will be less than minus 9. Therefore, upon multiplying with minus, the sign always changes, okay? So, minus 3x will be less than 0. Then, let us add 2 on both sides. Therefore, 2 minus 3x is less than 2 by adding 2 on both sides. Therefore, f of x is 2 because 2 minus 3x is nothing but here f of x. By substituting here, f of x is less than 2. Therefore, the range of f of x is minus infinity to 2 because it's clearly given, specified here, like f of x is less than 2. We derived that expression. Therefore, the range is minus infinity to 2. Let us see subsection 2. Subsection 2, f of x is equal to x square plus 2. X is a real number. Given x is a real number here, therefore, x square is greater than or equal to 0 by squaring on both sides. So, any real number, like when we square on this one, it will be greater than 0. Then, x square plus 2 is greater than or equal to 0 plus 2 by adding 2 on both sides. Then, it implies x square plus 2 is greater than or equal to 0 because 0 plus 2 is 2. X square plus 2 is nothing but here f of x. So, f of x is greater than or equal to 2. Therefore, the range of f of x is 2 to infinity, where the 2 side this is a closed bracket because 2 is included. The value of the 2 is included. Let us see third subsection. F of x is equal to x. X is a real number. Given x is a real number, f of x is a real number. Therefore, f of x is equal to r. The range of f of x is r. Thank you.